Hello and welcome back. Okay, today I want to convert a little bit more of the breadboard work into PCBs and finish off this side over here. So this is main memory. It's 32k of ROM and 32k of RAM, and I've got a couple of extra little bits of functionality I'd like to add to that as well, because the PCBs are a bit more dense. It would be nice to square away this side. Let's take a look at the schematic and PCB design. Okay, so I've created this stub PCB outline which has the position of the connections that I put onto that backplane PCB. So I've defined those connectors, and I've also pulled in a couple of chips which I know we need. So this is the 28C256, which is the ROM chip we're using, and the exact RAM chip I couldn't find it in the library, but I did find this 62256 which has the same package and pin out, so that's gonna work for us. So RAM chip can go anywhere. The ROM chip, we need a bit of space around it because we're not actually putting one of these ROM chips in, we're going to put the ZIF socket in. What else do we need? Right, the address lines are very simple, especially when someone's done a chip with the rearranged inputs. It's worth noting that on the RAM chip it doesn't really matter what order we connect up the address lines, because we'd just swizzle the memory addresses around a bit and then read them back with the exact reverse of that. Okay, so I'm just looking at my own video here as a reminder. So write enable on the ROM chip goes to 5 volts. On the RAM chip, now we did end up putting this delay in. Output enable needs to go through an inverter. Okay, so let's grab an inverter. I realise this ROM doesn't seem to have VCC or ground. That's okay, it's actually done that automatically. Well, the 16th address line goes straight into the ROM's chip enable, but for an inverter into the RAMs. Now, I am slightly worried about the fact that this inverter does stick a slight delay on the chip enable. So there's a couple of nanoseconds where you might have both chips enabled. Let's see if we can do that a different way. This is one of those 138 3-to-8 line decoder chips. And once again, this feels like complete overkill using it to just have 2 of the outputs. But they are designed for exactly this job, to solve the precise problem we're facing. And I've got a bunch of them. So now address 15 goes into A0, and we feel quite wasteful by pulling those down. Okay, well that feels like a bit of overkill, but it does take away my concern about timing and a little bit of bus contention. Okay, so mem load gets cascaded into write enable through 4 inverters. Okay, so that comes out at 2y. Let's stick it into 5. That will come out there. Put that into 3a. And it come out 3y into 4a. And then our result is here. And that inverter is unused for now. Okay, now I would like to display the current status of the address bus, because when debugging it's actually a little bit frustrating sometimes because you have to go through and work out what register is outputting and what the value in its latches are, which isn't always the same as its LEDs. Okay, very sorry, but I missed a whole chunk of pathing there. I thought I'd set it recording. Basically got these chunks of address down at the side done, and most of the data lines. For ground, I'm making all the connections, but mostly that's just to check that the path exists, because we're actually going to be doing a ground fill later. But for VCC, I'm going to use a thicker trace, at least for the parts that I suspect will be consuming more current. It's one of those jobs where you think you're almost done, but the finishing off stuff takes ages. Things I'm paying a lot more attention to the power and ground routes than I am the signals, apart from trying to keep these all together. put a couple of screw holes in here because I think I need some support behind this for when I'm putting chips in and out. Okay, so the build times are right back down to where they were. So let's hope things are getting a little bit better in China at the moment. And the thing is, the width of this is the same as the width of my address registers, and if I'd put a little bit more effort in and got them under 100mm, then it would save me quite a chunk on the PCB manufacturing. Okay, now I'm sure you're aware that I don't design the PCBs and then have them arrive instantly. There's usually a time delay. But this parcel got stuck in the postal problems, and that's what, the 20th of March. So I've been waiting for this one for a while. That's a new JLC gift on me. Okay, looks pretty good. Get it set up to solder. Okay, so I put the capacitors for the ROM chip on the back because I wasn't sure the space I would have around. This is where the ZIF socket goes. Right, I'm turning my soldering line up a little bit now. Okay, that's not like me. These don't match the same grid squares, so I can't use a piece of breadboard to line them up. Okay, partially I want to do this straight away, but that's going to make soldering some of these other components very difficult. Let's go with the big chip first. I actually noticed that this chip bag comes with both a sachet of desiccant and a little card to work out the level of moisture the chips have been exposed to. That circle is still blue, so we're okay. I suspect that probably only applies if you're going to a reflow oven. This memory chip is more RAM than the first two computers I used. Okay, so this actually feels like the chip isn't a brilliant fit for this pad. It's probably fine if you're reflowing it. Well, let's see what we can do. Well, that looks way off at the back. Okay, this looks like it would be absolutely fine if I was using solder paste and a reflow oven. I think they're all making contact. We shall see. So this is the 74HCT138. Now if you look on these chips, the way there's a big piece of pad next to the leg, makes it very easy to be sure that we're grabbing onto them both. Okay, so we've got 16 of these blue LEDs. So these line drivers are literally just here to power the LEDs, so I'm not powering them directly from the register boards. I don't know why, but capacitors are definitely the toughest of the components to solder. Okay, I really should have done these ones before I put those chips in. Probably okay, but because I put them that way rather than the usual direction I put them in, it made it difficult. It does occur to me. Okay, so most of these lines should actually be cross-connected, and these ones are not, which means my attempt at soldering these lines has not been successful. Okay, so I got the flux out and it's making a whole lot of difference here. Okay, so that one's not connected. It's definitely supposed to be connected. That's more like it. Okay, that's promising. Just turn it back up for through hole. Give it a moment. Okay, it's about now when I'm wishing I made the entire thing through hole. Okay, well that's all done. I'm going to get this cleaned up and then I will look at getting the main build back out and give it a test. Okay, let's get this thing out. Okay, now is this going to work? Reset light is on. Oh, that's not good. Okay, this chip at the far left is getting hot. I was expecting to go in and see a solder bridge. That chip is not the right way up. If you look closely, you'll see there's a nice spot on the stencil here to show you which way round it goes. You'd have to be an idiot to do that wrong. Now, in my last video, I had several comments from people saying how much better my soldering had gotten. So pride comes before a fall. Okay, let's try this again. Okay, we've got no reset. Yes, that's working. Okay, well, despite the mess around, this appears to be working now. That's great. I'm particularly pleased with that. It's odd when you have problems and resolve them and fix them. It's kind of more rewarding than when it all works first time. So I'm quite chuffed with this. It's obviously nice to have this whole rectangular section looking final. I have said I'm going to do a respin of this and a more simple respin of this at some point, because I don't need two main bus displays. I may just pull the LEDs off there at some point. I hope you found this interesting. I really appreciate all the support, and I will see you again soon. Goodbye.